So this is going to be part 3, section 10.3. We've been talking about polar coordinates, and now we're going to, trying to relate this all back to Cartesian coordinates that we know. So just like we can plot graphs of functions in Cartesian coordinates. This will be something of the form f of x, y is equal to 0. We can do the same for polar. Or y is equal to f of x, I should write there. Either one. We can do the same for polar. That is to say, if we have a function, r is equal to f of theta, or f of theta r is equal to 0, so either of those kinds of things, we can plot, what this is going to look like in terms of these, on a plot that we are familiar with. Okay, so let's jump into an example. So there's no step-by-step directions. I'll show you how to go through and think about this. So what we're going to do is, essentially what we learned how to do, when we were first plotting in XY coordinates. You would plot points and connect the points. So that's what we're going to do here eventually. So the first one is, what curve is represented by the function r is equal to 2. So this is asking, what points here satisfy the equation r is equal to 2? What points lie at distance 2 from the origin? Well, this is 2, negative 2, negative 2, 2. All of these points satisfy, r is equal to 2. All of these lie at distance 2 from the origin. Points here, 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 and here will do that. And you can see what I'm getting at. This is just the circle radius 2. So the curve r equals, whatever you want. It's just the circle of radius, whatever that radius is. Pretty simple. So let's do another one. Sketch the polar curve. I should label these. This is being drawn in Cartesian coordinates. So I have, a polar function represented in Cartesian coordinates. So we're going to sketch the polar curve. Theta is equal to 1. So again, we're looking for points, so 1 is less than pi over 2. So maybe, this is, that's the angle theta equals 1 there. And, I've already started here. Every point on this line lies an angle theta from the origin. If I continue that line, let me draw a little neater. If I continue that line, all those points also satisfy that, because these points down here are, you could have negative r theta here, and that would work still. So all of these points here determine theta equals 1. So theta equals a constant is a straight line. If you draw it in, the xy plane. All right, so let's do something a little more interesting. So sketch r is equal to 2 cosine theta. So this is going to be part A. All right, so what we're going to do for this one is we're going to set up a table of values. We're going to set up, theta values and r values. And from this, we'll be able to plot points. So we're working with cosine here. So let's use angles that are convenient. 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So these are all, values that I can easily plug into theta here. So theta equals 0, I get 2 times cosine of 0, which is 2. Pi over 6, cosine of theta is radical 3 over 2. It's going to be radical 3. Let me make rows here, just so I'm not, that's not enough room for some of those, but we'll make it work. So 2 radical 3 there. Cosine of pi over 4 is 1 over root 2, so this is root 2. Cosine of pi over 3 is a half, so this is 1. So I'm just plugging in, things into here and getting these values. So I'm just going to write the rest of them. Stop talking because it confuses me while I'm writing. And this would be negative 2. Now what I can do is I can draw these, with these angles. So at theta equals 0, which is the x-axis, I'm at, the point 2. At pi over 6, I'm at the point square root of 3, which is less than 2, so maybe we'll call that here. So at pi over 4, which is that angle, I'm at square root of 2, which is, still less than pi over 3. So I said it's less than pi over 3. So maybe there. Pi over 3, I'm at 1. Pi over 2, I'm at 0. Yeah, so this is gonna come out weird looking, but it's fine. So then 2 pi over 3, I'm at 1 here. Let me fix that last point up there because it's gonna make it look weird if I don't. Let me fix all these points because it's not gonna get the shape I want. So maybe there, and maybe there. That's better. I see what I was doing. So, everything I was talking about with those points still holds. I've just shifted them because it's not going to give me the shape I wanted. And then something that looks like these are these for points. And at, pi, we're at minus pi over 2. So that's actually going to be there. So be careful with this point because you have a negative radius. So when I, draw this, this is a circle. So it's supposed to be a circle. I'll mark that so you can see that. But it's a circle here. So what I've done here is I've just, I've plotted points and then I've used the r and the theta value to figure out where those points lie in the xy plane. And then I've connected the dots. Again, what I was saying with this one is, the point negative 2 pi. So pi is this one, but it's a negative radius, so we have to go the opposite direction. So it's the black dot that I just drew, which is the point 2. Okay, so that is going to be r is equal to 2 cosine theta. So let's do part B to this, pretty straightforward. So B is to find a Cartesian equation for the curve. Okay, so we don't want to have r and theta here is the idea. So what we have here is we have r is equal to 2 cosine theta. So we're just gonna, so what we have to do for this is we have to try and play around with all the different things we have in terms of, I know cosine theta is equal to x over r. And, I have all my other ones. Sine theta is equal to y over r, and so on and so forth. We'll really just need the first one. So this is a matter of, there is no clear-cut way of doing it. You just play around until you get something that works. So cosine theta then is x over r. This is 2x over r. If I multiply the r over, I'm going to get 2x is equal to r squared. Well, I know x squared plus y squared is equal to r squared. So if I replace r squared with x squared plus y squared, this gives me, a Cartesian equation here. I'm going to rewrite it though. So I'm going to get x squared minus 2x plus y squared is equal to 0. So I'm going to do this just so we can see, what this actually is, and show you that that is in fact a circle that I've drawn there, even though it's doesn't look like one. So what I'm going to do here is I'm going to complete the square. So completing the square, you add and subtract b over 2a squared. So b over 2a squared is 1 in this case. So I'm going to get plus 1 minus 1 plus y squared. And then this term is a perfect square. This is x minus 1 squared. Minus 1 plus y squared is equal to 0. And then I'm going to move the 1 over. X minus 1 squared plus y squared is equal to 0. This is the equation of a circle with center 1, 0. So it's a shifted circle there. And you can see, from this picture that I kind of drew up here, this is the center circled at 1, 0. Okay, so I'm going to actually stop here. We're going to continue on doing a few more of these curves here. So let's go ahead and stop.